much. So what I thought I would do, I'm going to have obviously my presentation, and I would like to probably with the questions and answers, probably I would prefer them to have as we go rather than wait at the end, just because I prefer to have a nice conversation about some of the topics that I'm going to present rather than having to wait, because it is quite ambitious in terms of the material that I want to cover, but I just, well, want to do my best to try to do that. So first I will have to want to acknowledge my supervisors, which is David from the school, and Rick Llewellyn from CSIRO, and Liz Wedderburn from Ag Research here in New Zealand. So then what I'm trying to do then is follow this this outline. I'm going to give an introduction. I'm going to broadly talk about the research components of the whole research, but then just focus on some of the highlights of all these components and spend some time in that, probably what I would consider that is perhaps a bit more interesting for this audience, and then some conclusions. As I said, questions, anytime that you have one, please interrupt, and then we discuss those ones. So for those who heard me talk last week at the conference, I'm going to be broad at this time. I just really, that last week was just about one of the components in more detail, but I want to expand a bit today. So first, the focus that I wanted to give this research is from a modeling perspective. I'm a modeler myself, and I spent several years studying that and trying to look at that at adoption from that angle. And the aim really is to try to make better predictions of adoption of agricultural innovations. So the research consisted of 4 research components. So I'm going to talk about them briefly: a systemic review of conceptual models, adoption, a meta-analysis of numerical models. Then what I presented last week, which I'll touch again today, is adoption pathway analysis. It was a case study done for defining that. And then another component that was looking at the usefulness of models particularly for extension, for assisting extension planning. So if I want to come back a bit to the actual literature on adoption in agriculture, I would like to give a brief timeline of how I understand things progressed. So it all started about the 1950s, and probably the first important piece of research there was released in 1957, and looking at adoption from an economics perspective. And this study, probably what it did, from my perspective anyway, is just normalize the use of regression modeling for studies of adoption. Just about the same time, Everett Rogers was developing the diffusion of innovations theory that became really influential in the field. And according to this sociological theory, what really decides mostly what the decision to adopt these individual perceptions about the innovation attributes. Then following that, there was Bass' model, or how he actually decided to model the diffusion of innovations theory that gave place to what we now are all very familiar with, that S-shaped curve to represent adoption. And then that's still quite influential in studies today. And that is originally done from a perspective of marketing. And I can just say from now that's about market penetration. It was originally done for first purchase of domestic goods in that case, but somehow it just became quite mainstream. And later on, but in the early 90s, it was the theory of planned behavior, and that's a psychological theory based model. And in there, really is trying to understand the internal process of rational decision making, but also influenced by external influence like social norm and perceived control. So those four, in a way, important research pieces inform the field of adoption, and they keep doing so. And later on, I would say that in 1985, that work by Feder, Justin Silberman, that became quite important for adoption of innovation in agriculture. So they actually defined a framework that I will touch in a minute that would actually probably set the scene for a growing number of studies done in agriculture specifically. So that framework recognized it in a way, established that adoption in agriculture is dynamic, that the different parameters will actually affect farmers' decisions at different stages, and that the actual process itself is very heavily influenced by learning. So that's gathering of information, learning by doing or trialing, accumulation of resources to actually make a decision about adoption. And at the same time, they also established the practice, well, that really, in order to model that, what we needed to do is use a production function. In this case, they proposed that it was a expected utility of profit, and the constraints were there about the specific characteristics of the technology, but also the decision maker. So in that original study, they proposed these parameters that are here, but since then, and I'll touch that later, it just expanded enormously. In their study, they use farm size, tenure, risk and uncertainty, human capital, labor availability, and credit and supply constraints. So they are, as I said, the initial set of variables that they looked at, but that evolved in recent studies. So after that paper, I did a quick search and found that there's about 5,000 plus studies or papers on and then, but since then as well, there's been about dozens of conceptual models. There are many conceptual models. There are hundreds of adoption drivers that have been used in those models, and there are thousands of mathematical models that have been actually done in the area. So there is a great difficulty in making sense of trying to have a synthesis for modeling purposes. So there is a lack of agreement on what actually drives adoption. There is a recognized need to have better definitions and measures. And there are multiple objectives, areas of application, and it's conceptual, theoretical understandings of adoption. And of course, the obvious thing here is that adoption is a complex problem, and as such, the actual precise behavior of any complex system just cannot be forecasted. However, it becomes very important to understand the principal laws. There's patterns that can be recognized in order to amongst all these interacting units, in order to try to be prepared for the future planning. So Dave has said, and I've been quoting this, but at the end of the day, what we observe is that each practice has its own adoption story. So there is a unique combination of a practice, a population of potential adopters, and the context in which the adoption takes place that is unique for every case. But within that, then is it possible to actually recognize common patterns or principal laws? So that's what this research is about, really. So I touched on this last week, but what I'm presenting there is the BAS kind of base model of curve of adoption that we are familiar with, and that can be used to have a good understanding perhaps of peak adoption and adoption speed, but not necessarily on the duration or extent of use that are actually important for us to know. And this is a bit more detail on those four. Outcomes. So peak adoption obviously is the cumulative number of new adopters that come on board to use a new technology. The adoption speed is the time that takes, what shapes the S-curve in terms of how it leans, and then the duration of use that is not reflected on those curves, which is really the time that the practice is actually used within the target population, and more importantly, the extent of use, which is a measure that is different from the other three because they are not expressed as a number of adopters, but is actually the intensity or the could be the number of hectares or can be the actual frequency of use. So that by approaching adoption modeling in a traditional way, then we might be missing out on this. So most importantly, I think that what we found in these initial stages of research is that the influence of Rogers' theory of innovation is that by putting too much emphasis on the actual adopters, it has distracted a bit the research field. People seem to be much more interested in knowing about the adopter and even or the context in which adoption takes place at the expense of innovation related variables. So as they say, if a practice has been promoted for years and years and years and is not really popular, then the problem really is with the practice, not really with the farmers. But these areas, these sentences make common sense, but in practice, you still see not being applied in some research papers. So that's what we started noticing from the beginning, that there is an imbalance in the literature. So that's the introduction. What I'm going to do now is explain about what I've done on the review of conceptual models. So this is what I did. I came up with this way of organizing the models. I selected the models that you can see in this slide to illustrate the different approaches that have been used over time, but also the different, almost examples of models that I situate in this matrix with 2 dimensions. In the one, whether those models were more around knowing the adopter, ones that were more around the technology itself, and on the x-axis, the grid is whether they are about the rational process of decision making and whether they incorporate external influences. Those are the extended behavioral models. So you can see in there, for example, the adopt model that I use quite a bit on the other components of my research is right in the middle. It just has a way of balancing a bit the approaches that we can see in here. I'm going to show you a couple of examples. I'm going to show about 4. I'm going to cover them briefly, but I will give you an idea of the models that I identify. So this is the first one that is, again, probably people are quite familiar with it, is the theory of planned behavior. And as you can see in here, there is that rational decision process reflected at the top there. Those behavioral beliefs or the outcome evaluations, what we actually experience by observation, that inform the attitude, our attitudes, but also then some motivations to comply and just external influences that would actually, all of those inform our intention to adopt in this case, and then that leads to behavior. You can actually notice here as well that in most of the models that I'm going to show anyway, in general, there is a certain amount of subjectivity. It's very difficult to actually come up with variables that actually measure any of these concepts in many cases. So that's again to be taken into account. This is another one that I looked at, and this is more reflecting a bit what the process of learning is for agricultural adoption. So we actually have stages, and in this case is information flow, is a discovery stages, non-trial evaluation, trial evaluation, and adoption. This became quite accepted in agricultural adoption as a model for process, as an adoption process. And it's about recognizing the opportunity of a new innovation to the farming business, and then gathering information about it, learning about it first, not necessarily trying, then learning by doing, perhaps with a trial, until the level of uncertainty about the performance of that particular practice in the farm is reduced. Then we actually, if we're satisfied, then we actually adopt. This is a different way of looking at it, and this comes from fitness, task technology fitness. Here at the bottom, you can actually see a bit of that theory of plant behavior, which is the theories of attitude and behavior here. But on top here, then what you can see is that knowing the match between the characteristics of the task at hand, the technology that can be used to perform those tasks, and some individual characteristics that would actually make those more favorable than others. So that's the task technology fitness fit. But what is important from here is to recognize that the task, we need to understand the task a bit better. And there is already probably a technological solution in place already. So we actually need to understand better what the new technology is relative advantage in relation to the existing technology, and then just match that with the characteristic of the adopter. And I won't go into much detail here, but I just wanted to show you the adopt conceptual model that, as I said, it just has in the right-hand side, has a bunch of variables relating to the relative advantage, and in the left-hand side, about learning about that relative advantage. At the top there, what we have is variables related to the population of potential adopters, and at the bottom is a bunch of variables relating to the actual innovation. So this that's why I situated this model at the middle, because it has all of those components in there. So what I found from here is that obviously then it's very important to consider timing in this, and obviously try to understand adoption as a process over time. And in a way, probably that producers will be much more receptive to learn about, if learning is involved, they'll be much more actively learning about something that is perceived as highly relevant now than that something that might be relevant later on. So that's the first thing. And that, as I said before, the new technologies have to compete against existing technologies or practices that are already delivering benefits. So in many studies still, the benefits of something new are kind of taken for granted, you know, like that in so many cases don't even mention what the relative advantage of a new technology is, because they say, well, it's new, therefore it's better. So it goes along, so that's observed actually. And then that the adopters and the technology interact on a one-to-one basis. So the interactions are important to consider. And again, that's not really quite observed in many cases. So the next stage then was to look at the variables. So that's that gave me an understanding of what alternatives were there to actually model adoption. And in this case, this was about what variables are actually used. So to do that, I tried to do a metadata analysis, but there's several done, and they are all probably don't come to many conclusions about commonality about studies, rather than accentuating the differences that exist. And probably mine wasn't any different, but probably I wanted to prove a different point, I suppose. So what I've done, I took a sample of 100 studies, and from those I selected regression models that were done within those studies. So in many cases, I presented several, but so I have those examples of adoption from those studies, ended up with about 167. And I just could use a vote count method. I just identified all the different variables that were used in those models. And then I just recorded whether they had been found to be statistically significant or not, and the direction of the effects. Then I was able to run some t-tests just to test the consistency of both the significance when they were included in models and the direction, the ratio between negative and positive. So I'll show you a table that might look a bit scary, but we'll just tackle it. I'll explain what I've done here. So if we take as an example here, the very first one is a convenience. It's in the category of characteristics of the innovation, obviously. Then in this case, there were 48 examples identified of this where this particular variable was included in the model. And in those models, in 37 cases, it found a statistically significant positive influence of visa convenience in adoption. In 10 of those examples, it was not significant, and it was one example in which it was significant, but a negative effect. So what this last two columns indicate, if it says significant, means that the ratio of statistical significance over non-significance is consistent. So the variable is consistently found significant. And the last one there is the direction, whether it was consistently found to have a positive or a negative or none. In the case that they are blank, means that there were mixed results or too many, too few. And in this case, for example, investment costs, it was included in 45 examples, but it was consistently found not significant. So even though it was included, but that didn't mean that it was actually significant. So that's the way of interpreting this graph. And as you can see, we have characteristics of the innovation, we have characteristics of the adopter, and some contextual characteristics here at the bottom, and with various degrees of results. Now, this became more apparent. Of course, what you can see immediately without looking at the numbers is the fewer number of characteristics of the innovation variables included in those examples, as opposed to the rest. And that's become more noticeable when I divided that into categories of types of innovation. So in this case, for example, we have category looking at automation and information technologies. We have increasing yield, pest and weed control, soil conservation, environmental practices. And you can see here that in some of those studies, hardly no characteristics of the innovation were included in those regression models. And there were various degrees of the other ones, but also the level of variables that were included in models, but were found statistically not significant. It's also quite staggering, especially in the environmental practices categories. There seems to be quite, don't know what's going on. It just doesn't seem to be quite clear what is actually driving the adoption of those practices based on these results. So from this analysis, what we found in a way, or we were able to confirm, is that lack of agreement in the way the adoption is defined, explained, and measured. So Wilkinson gave this quote that I think is quite apt, that the word adoption is so entrenched in the language that everybody who uses it thinks that they know what they mean by it. And we carry that bias when we do our studies. So there is also then, there are some problems or implications for agricultural extension policy when you think that there is no clear indication of what actually drives adoption. You know, like the lack of convergence towards this consistent explanation is not there. So it's very difficult as a researcher, especially working on your own, trying to come up with a new experiment or a new way or a new study. And as an overall result from this, just confirming what we found in the introduction, is that many researchers have chosen to focus too much on understanding the adopter and not enough on the innovation and their interaction between the two. So the next, the component was what I presented last week, but that's basically, I defined a case study, and I will explain them for people who are not familiar with them. The 4 practices that I chose to do this study. I designed a survey, recognizing that cross-sectional surveys are the main tool that many researchers still have for carrying out adoption studies, and that's because they're cheap, they're accessible, they're easy to do, and it's just the way it is. I mean, there are longitudinal studies, there are duration studies, but they are more difficult to actually get on the way. So I defined an ordinal scale of adoption as opposed to a binary one, and I used the adopt model, conceptual model, to design a survey for farmers to answer. So I could use that to try to explain the differences between adoption of the 4 practices. Then I developed some graphs that, in my view, reflect better the nature of adoption as a process rather than as a binary decision. And then I just did a statistics model. So the 4 practices, if you were not here last week, you could, I'll explain them briefly, is the use of body scoring, the body condition scoring, use of pasture management software, use of plantain and lucerne for summer grazing. By the way, plantain is not the banana. Some people wanted, I mean, didn't know what it was. It's a crop. And the use of formal audited nutrient management plans. So all of these ones are really well established in New Zealand. They've been available for, I don't know, 20, 30 years, but they have various degrees of uptake. It was important to have these historical examples just to be able to test the questions, the research questions, not necessarily project them. So the survey, it was an online survey. I got 152 responses at the end from farmers, and it took about 15 minutes to complete. Because there were so many questions, we decided to only ask about 2 practices per farmer, so they didn't have to answer the questionnaire for 4, so they only asked 2. But in general, we got about between 66 and 69 responses for each of the practices. So body condition scoring is just the assessment of the body fat in cows and ewes. And in this example, we're looking at a cow, and that's done visually. If it was a ewe, because of the wool, they have to use thumb and fingers to actually do that measurement. But that is used for animal management, so to determine the amount of feed that is required and also reproductive performance. Pasture management software is basically using computer-assisted or computer technology to forecast to calculate the availability of feed per paddock or per farm or whatever. Can be used at the beginning of the year for strategic decisions about how much livestock to keep in the farm, or it can actually be used as a tactical tool as well, hooked to weather data and things like that. Can actually have a weekly or like monthly prediction of pasture production per paddock, for example. So this is a photo of plantain there at the top, and then lucerne in the main photo, and those are used as as summer grazing supplements, or alternatives to grass, ryegrass or clover. That is the normal feed for these animals, and it's just to increase basically the soil moisture retention in the case of lucerne, and just to basically plantain is also used to reduce nitrogen leaching in dairy farms as well. And the last technology was formal plants. Is becoming a bit more of a requirement for farmers to keep track of or reduce the leaching of nitrogen and phosphorus, especially in waterways. And there is the possibility of legislation being introduced in this respect. So I think there is quite a lot of interest from farmers to voluntarily uptake farm nutrient management plans now. So they look at aspects like fertilizer application and effluent pond management, and stock exclusion from rivers and lakes, for example. So this is done with a consultant or part of the environmental plan with the council. So there is several ways in which they can be done. So as you can see, there is it's quite a bit of variety on these four. So well, then I'm going to touch about the what was different about this study from previous ones, and that is basically using a set of questions to determine adoption, more on not as a binary process, but not as a binary decision, but as an adoption process. So these are the stages of adoption, from the awareness of the problem or opportunity that the technology can actually be used for, non-trial evaluation, trial evaluation, adoption or not, start using it basically, review and modification of its adoption, which are in a continuum, and they are often revised. So they are not really the same for every one. And that's where I'll touch on this later, but that point in there is where we normally define adoption binarily, just to start using it or not. So these are the questions. So there's 7 questions. This was used to assess the current level of use. So rather than do you use it? Yes, no. What we use is 5 categories there. So from people who have never used it and used it in the past but not anymore, to 3 different levels of use now. And that is minimum extent or moderately or maximum extent possible, according to their perception of how the level of intensity or extent of use, basically. So then we ask whether they had used it on a limited basis, whether they could have identified a trial period for it or not, and whether they're having any changes on the level of use since they start using it. So whether if they're someone who's using it moderately at the moment, then we ask them, has that always been the case, or do you use it more intensely in the past and now you've reduced its use, or increase it, or remain the same? And then we ask a timeline. We ask them to remember approximately when did they become aware of the practice. As I say, all of these ones have been around for about 20, 30 years. And then when did they start trialing or using it? And then whether they were intending to make any changes in the future. For the current users, where do you want to increase, decrease, or remain the same? For non-users, is whether they would be interested in adopting or not interested. So that's what the graphs that I'm going to show you next were based on. The graphs of adoption that I came up with are based on this information. And then this is just a key for understanding the color of the graphs. So there in the middle, we have the actual scale that was developed. I got feedback last week. We just have to be quite careful about calling it the validity of calling it an ordinal scale, whether those different categories there are actually sequential and pass the test. I didn't do enough testing to see that they were actually completely valid. But I mean, I'm encouraged by the results I'm going to present later, but there is some discussion about that. But anyway, so it's going from the bottom to the top there, and using a traffic light kind of coloring. We have users that are not aware even now of the innovation, those who never adopted, assuming that they probably went through a non-trial evaluation and decided not to adopt, those who disadopted the practice, and from 4 to 7, they are the users that are, well, the farmers that are actually using it now. So as a trial, and then 3 levels of use at the moment. The ones that decrease the use since they adopted, the ones that have been using it constantly or increasingly in the short term, and the ones who actually have used it consistently or intensively for more than 5 years, so the long-term users of it. So the reason for doing this is because when you want to measure the benefits of adoption, in some cases you just want to measure yes, no, binarily they use it or not. But in many cases you actually want to say, for example, whether the benefits would actually come after a period of use, constant use, or extension of land or whatever it is. So that's the thing. So if that's the middle there. So if we look then at the past, because of those questions that we asked, we also were able to determine whether where the current use got to, whether people use trials or not, basically, from when they became aware, and how relatively quicker they adopted if they identify a trial or not. And the feature is just about the intention. So I said there were a couple of questions there for current users, whether they have the intention to make any changes to the use of the adoption, and the ones that are not using it at the moment, whether they will be interested. So the graph looks like this, and basically what it does is just, as I said, from left to right, just takes you from the initial point of awareness, and they are not at the scale, but the placing of the bars indicate whether data showed a difference in terms of the speed of adoption, basically, while using a trial, or if a trial was not identified. In this case, people who could identify a trial adopted quicker than the ones who didn't. But whenever it came to the current level of use, what we can see here is that it didn't make much difference for this particular practice, whether for long-term users, whether they had actually started using it with or without. It's about a 50-50 split. However, for example, for this adoption, what this shows as well is that this is twice as likely for someone who started using it without a trial to later disadopt than people who actually identified a trial. So numbers are small here, but at least it just shows a bit of a depiction of how we could actually represent adoption in a more informative way. And this is the graph for intention. So in the middle there is the current status of all the adopters, whether they are users or not users. And then at the right there is the intention. For those who are using it, whether they intend to increase its use or remain the same. And at the bottom there, whether they are interested in adoption or not, if they are not using it at the moment, or if they disadopted. So for this particular practice that we can see, it seems to be quite stable. Don't really seem to expect any major changes in the intensity of use from current users. And also there's not seem to be not much interest for those who are actually not using it in adopting it in the near future. But what gets interesting here is when you actually look at them and compare the 4 practices and the patterns. So you can start seeing quite a difference in terms of I mean, pasture management software seems to be slightly different from the other 3. In all the other 3, it seems like start using it with a trial seems to be leading to faster adoption. And also in the case of the disadoption is the same as a main example, that it seems like people who did not trials seem to disadopt easier. But again, numbers are small and it's not proven. But it raises questions about when you put them side by side on how to contrast the difference there. But the important thing here, I think, is just the way we currently measure adoption as a binary variable. In many cases, invariably, because you normally don't take this adoption into account in studies, then you end up overestimating the adoption rates. So if you are actually after a binary adoption, whether people have actually used it or not, that's a number. If you are only interested in current users, then that's a dramatic decrease in all of them. But if you are, for example, interested in the long-term uses of a technology, then the numbers are quite different from the first estimation of adoption as a binary variable. I'm going to I'm going a bit slow, but then what I've done then, as I said, I tried to test what were the reasons behind, or try to explain those differences by running so I'm not going to go in detail, but this is what I done. As I say, I use the adopt conceptual model to define this question. So for example, the first one, they just and this is what I'm going to present in the next table, but the profit orientation of the farmer. To what extent is maximizing profit and motivation for your business? So I use a Likert scale in all these cases. So this is the variables relating to the adopter, and then this at the bottom are variables related to the practice itself. So the summary of results for this would be like this: profit orientation, the minimum would be a 1, the maximum 11, so it's a Likert scale of 11 points, and then that's the summary data. But this is the actual result of the ordered logic model. So I use the ordinal scale as the dependent variable, and all of these variables as dependent variables. So I included also some of the interactions, being in this case profit orientation and profit advantage of the practice, environmental orientation and environmental advantage, risk orientation and risk advantage. So again, what you can see here is that the three practices seem to have quite a strong component of relative advantage in terms of profit here, and environmental benefits, for example, even risk advantage. But the nutrient management plan practice seems to be driven by completely different variables. The only variable that seems to be quite constantly important is the enterprise scale. That comes back from that first study I showed you in 1985. It's one variable that has been consistently being used in many studies and found important. I just wanted to show you the contrast again. I don't really have many answers at this point, but just wanted to do this as an exercise of trying to understand better. So what I found from this one is that the ordinal scale seems to be better than the binary scale because it's more informative, and it just seems to be better at accounting for a process. of adoption, and it's encouraging. As I said, it's not perfect, but at least it just is being robust. I use the crunchback test to test for the validity of the scale, and it seems to be fine. And it can actually work, as I said, in cross-sectional surveys, which again is our main tool. So I wanted to test that. And accounts for that subjective assessment of farmers, they are actually the ones who can actually say whether they're using it extensively or moderately or not enough. But that can actually be further, you know, like the scale, well, the questions can actually be tailored to say what would be a minimum extent for management, nutrient management, or what is the minimum extent for plantain on lucerne. So we actually can establish those parameters a bit more customized, in a customized way. So the last component, then I say, well, there's plenty of literature showing that when you compare the model that is used for assisting planning or the process that is used around that, if it's a good process, people who participate in this exercises seem to consider the process better than the model itself. That hadn't been done in extension, so is what I did. But also using ADOPT was a good opportunity to not only look at the model's outputs against the process, which is what you normally see in studies, but different components of the model. So in this case, there were three components of the model that were tested separately. So first it was 3 workshops. People just participated in one, by the way, is because they were 3 different locations. So there was no repetition, but at the end it was 34 extension officers. And there was a pre and a post workshop questionnaire that then I used to run some models. 24 completed both, so that limited as well my ability to run a model, a statistical model anyway. And the workshop basically consisted of asking them to choose one of those 4 practices that we saw before and then run ADOPT. And then these are the 3 stages here. So first it was a presentation about the ADOPT conceptual model, which is the first component that I consider of the model, then running ADOPT, and then producing a diffusion curve and compare that to the estimate for the selected practice based on the survey. And then we use ADOPT sensitivity analysis to adjust that. It was not a validation exercise, but it was just a learning kind of to talk about the assumptions that were driving those discrepancies. So the 3 components of the model in this case were the conceptual model, the model outputs. Yes, Sasha?
We have a few minutes.
Oh, yes, sorry. Yes, yeah. Okay.
So if you can.
Yeah, I'm rushing now then. So again, just in a graphic way, step 1 was the presentation about the conceptual model. Step 2, the actual results of the model. And step 3, a discussion about the sensitivity analysis. So these are the results of this. I'm just a couple of slides away anyway. So the participants' changes in opinion before and after the workshop, whether their opinion about being able to predict adoption adequately changed, and there was a change in the attitude that people would actually agree after the workshop. There was an increase on people believing that it is possible to predict adoption adequately from the beginning. And the ones at the bottom is again, I just wanted to kind of test whether they consider the characteristics of the farmer or the practice or the external factors important or not. So these are the changes in the workshops. And when it came to actual usefulness of the different components, this were the results. So no surprises, but the process of group discussion was considered useful by everybody. The conceptual model was the second most important one, followed by the sensitivity analysis, and again, consistent with previous studies, the actual projection was the least, considered the least useful, even though ADOPT was able to produce an adequate curve. So this is just what I said. But importantly, probably is that because we often think that the model is when we make a model, we think that the results are the most important part of it. What this study shows is that people are actually quite interested in understanding what, if you present the conceptual model and then you build a good transition from the conceptual model to the actual modeling exercise, and then you give them the opportunity to change the parameters so you can actually see the effects that it has on the model, that is quite powerful. So rather than just producing a model aimed as a black box to produce results, what it shows is quite important to consider all these features when considering a model like that. So that's the end of the presentation.
Thank you very much, Oscar.
5 minutes to go.
Yeah, 5 minutes to go. If you have quick questions, this time now.
Can I think I can't formally raise my hand because I'm a co-organizer. Anyway, thanks, Oscar. 2 comments, I think. One, the lack of characteristics of innovations in the studies. I'm wondering if that's in part because you're doing cross-section studies and by definition, in some sense, the characteristics the same. It's an innovation and therefore everybody's getting the same thing. And then what the studies then, if they are going to have anything about the characteristics of the study, they're going to have to rely upon the respondents' perceptions of the characteristics like profitability and I'm just wondering whether that then runs into the problem about endogeneity, that only adopters know about that, and that sort of limits people's use of those types of variables. I'm trying to think about processes which might have reduced the prevalence of characteristics in those empirical studies. I'm just wondering whether that's whereas I can easily measure farm size and age and all the rest of it, those differ. So they're easy to bang into a model because they just by definition vary across the sample.
Yeah, I think that could be possible, Michael. But I still even if it was just perception, in many cases they wouldn't even ask, do you think it's profitable, without actually having to do. I mean, there's some studies out there that would probably not even, and in many cases I think it comes down to having the innovation itself really poorly defined. So you actually have studies that say adoption of best management practice. So what is that, and how on earth do you actually measure any characteristics of that? And that's not uncommon, especially on environmental practice. The one that seemed to be a bit better are the precision agriculture or precision agriculture studies, and that is just probably because there's more gadgets and it's easier, discrete gadgets. So it becomes harder with practices, becomes in a bit easier with actual physical innovations. Yeah.
Ram, you want to raise your question?
I think it's a simple question. I wrote there, Oscar, in your presentation, you referred to the interactions between technology and the adapters. What do you mean by that? What are you referring to? So I was just curious because we have many students working on the adoption topic, and that might be a useful elaboration.
Yeah, I think, well, just narrowly talking, you know how we often use regression models, and we tend to either say use profit advantage or profit orientation. We don't normally interact them in models. We tend to kind of use one or the other.
So basically, including interaction terms, you mean that's what you refer to?
Well, that's one thing, but what I say is that because say for example the idea that I have for the task technology fitness, that we have to understand really well what the task at hand is, and then match that with the technology options that are in front of the farmer.
Okay.
And then the characteristic of the farmer themselves. So that's often missing. As I said, in many cases, the benefits of a technology, of a new alternative, seem to be overlooked. Is probably what I really mean by this.
Okay, thank you.
Thank you, Ram. There is one more question from Steve. Steve, you want to ask the question? It is in the chat. Yes.
Yes, I worded the question in the chat. Perhaps it's better yeah, than asking it. I'll let Oscar have a look at it, and I don't know. Or just a clarification, really, I think.
All right, let me have a look. Yeah, I see what I mean. Yes, I think that, yeah, I mean, for calling it improving prediction adoption, I didn't really do much prediction, did I? But the thing is that I think that there were some, detected some really fundamental problems even as I said, just the fact that there's no real good definitions out there, there's actually not real measures, then it's quite difficult to then try to predict. However, I think coming back to probably if I learn anything from this and coming back to one of my original points is that the complex problem cannot be precisely forecasted. It will never be, but we can do a lot in predicting the adoptability of an innovation, and that is really stripping down to perhaps what would be useful is just looking at of that, really trying to strip a bit the context and just trying to look at the essential relationship between the relative advantage of a practice with the adopter. Yeah.
Okay, thank you. I guess I was also looking at it from the point of view of someone who's developing, or a company who's developed a new technology, and they or is thinking of developing a new technology, and they want to know what is the likelihood of its adoption by a farming community. At some point, they would want some measure because they want to know what is the expected adoption rate that will translate for them into return on investment. So it's, of course, it's going to be uncertain. So there's going to be risk involved. But I think in that case, it's going to be looked at like any investment, a risky investment, but they still want to know what is the likelihood that they are going to get their investment back. So if it's not adopted, of course, they will have lost their R&D investment.
What is the probability that in their market penetration, in other words?
Yes, well, yeah. So I suppose there's always that question in the background for the developers of a new technology.
Yeah, that's right. I think I looked at all of this just from a very theoretical perspective, but in practice, what you get is what you have, and that's a common practice, is guesswork and optimism, technological optimism. That's what you normally see. But it's just trying. It's almost my plea is almost like saying, you know, the same way that we treat adopters at the moment with those early innovators and laggards and all those segmentations that we're using? Can we do something smart about technologies themselves? Can we actually have a better understanding of a type of technology and then match that future expectation according to what we know from the past about similar technologies in similar circumstances? We don't really have enough, I don't think, depth into understanding the technology itself. As I said, everything is being distracted by trying to make the laggards adopt.
Thank you.
Okay. Thank you very much, Oscar, for very interesting presentation, and you covered a lot of details. You were trying to cover the whole thesis. So thank you so much.